Hello, hi everyone. In this video, today we will be covering what is Turing machine, what is the formal definition of Turing machine. Then finally, we'll see one of the example how to design the Turing machine for given language. With this, straight away move to the what is Turing machine. Just have to start introduction. Before giving the what is Turing machine, why Turing machine, there is a lot of differences between the other automata, that is the finite automata and push down automata. In this case, let us see what is finite automata. Finite automata we have learned it. So there is finite automata is accepted regular language, accepted by regular language. Then PDA is accepting context free language. Then understand that finite automata have a data structure code. It is a there is a input string. It is like a B A. Say one of the string. It can be anything. In this example, I have taken the input will be like this. You can read it from the left to right. Okay. It has only finite number of string it can accept it. That means it is a finite memory. So it is a tiny memory. It's not, it is accepted or not accepted, it will be saying immediately. But PDA, it will be have some additional memory called stack along with the input strings. That means there is a stack control. It is say accept and reject. At the same time, any string has been processing it, it will be store the intermediate string. Later on, it can be retrieved for the process for the further process. So that's what any uh, complicated complicated language, it can process it as more powerful than finite automata. Let's move to the next machine, that is what we have to discuss today, Turing machine. This will accept a better than more complicated language as compared to PDA and finite automata. That is called recursively enumerable language. Some languages is not possible to solve by PDA or finite automata. In that case, you need to have some more powerful computation. Such case, we have to choose the Turing machine. Turing machine data structure will be like this. Input, strings, tape, a special symbol will be there, and control portion. This control portion will be available in the rest of the finite automata, but these are the tape will be there. So tape will be like looking like this. There is a input. You have an input, and tape head will be pointed to the input tape. So you have a input. So there is A, B, B can read, and each head of this either side of the head can have a delta. That is, a delta is indicated a blank symbol, right? So that indicates a end mark of it is a B here. Okay, let us see that how this head is reading the input from the input tape. Okay, look at that. Tape is capable of performing following three operations. The symbol, that is head, is pointed to one of the input tape head, input tape. So that is called, first operation is read a symbol above the tape head. You'll be reading it. Look at, for your understanding purpose, I am showing it in a color coded. That symbol, suppose it was in the black color before reading it. After reading it, it becomes red. Right? What is the next operation? It can be modify that symbol, this red symbol, or update it by some other symbol above the tape head. So in this case, I'll showing it that whatever that A read it is replaced by small b. Okay, this is in case I have showing only for the example purpose, that based on the designing of Turing machine, it is left to you whichever the symbol you can modify by replacing any other symbol, that is left to you people. Then what is the last operation in this? The head is can either move to previous square or next square. It can be moved to one step to the right or one step to the left. Look at that. Head is moved one step to the left. Like that, it can also move to the one step to the right. Right. So I think hope you understand this. These three operation is need to follow it for your further Turing machine design. Okay. Let us move this Turing machine as a control portion. I will explain in the previous slides, and also input tape. So always control portion is pointed to the input tape. Input tape as a pointer, it is a head pointer. So that means it's a control portion plus tape is nothing but a Turing machine. So once you understand this narration of how this Turing machine works better than the finite automata and PDA, let's move on to the form. So how this has to read the data. Okay, have you seen already operation to perform by Turing machine TM. One, it can be read or modify, update, or head is can move one step to the right or one step to the left. Left means is a previous, next means is a right. Okay, so that means look at that how it can be indicate. These are the conventional way of designing a Turing machine, that is nothing but a transition diagram. Suppose you have a input state is Q0 is a initial state. It can read a data, it can read a input. At the same time, after reading A, you are replace that A by B, that means update operation, and that R or L or S is indicating, R is indicating one step to the right, or L indicating one step to the left, S is indicating one step to the stop. Okay, so in my future problems, in the next problem, always using these letters for all indication of left, right and stop. Okay, so once you understand what is read, update and shift, along with that other operation also will be there. In this case, look at that, all it has been changed, right? So that A is read it, B as replace. Okay, it moved to the one step to the right. So because of this R, it is tape head is moved to the right. In some other example also, you can see along with that, you'll read B, then replace that B by A, that means update A and move one step to the left. This L is indicated left. Other one is read A and update it to the delta, that means A is replaced by delta, move one step to the right, R indicate right direction. So another operation will be like this. So read A, replace same symbol by small a, so move one step to the right. Okay, that means there is no changes. We'll retain A, read A, updated by that letter itself, move one step to the right. And another one, so another operation will be like this, move read A, that A is replaced by capital A and stop it. So these are the four operation other than this, right? You can able to use it for in your further problem design or Turing machine design. So once hope you understand this all operation, conventional operations, please you have to be try to understand, listen the video again and again, so then it is easy for you to understanding designing a Turing machine for given. Yeah, now you can see what is a formal definition of Turing machine. So it has defined by 5 tuples, that is T is equal to Q sigma tau Q naught delta. Then what are this? Q is a finite set of state. Assume that HA and HR is not part of the capital Q, that is nothing but we are indicating these symbols. H is an accepting state and HR is a rejection state. Then so sigma is a input symbol and tau is a tape alphabets. Then Q naught is a initial state, is an element of capital Q, and delta is a transition function. Okay. So now let us understand that once you understand the definition of Turing machine, let us move to the example of Turing machine. That means it's accepting a B star A. So how to design a transition Turing machine for this? Okay. So first you have to try to understand this, what kind of string it can generated from this string, what in this language, that is nothing but this A B star A. So language will be like this. That means the string accepting in given language are R. So it can have only that B could be have any epsilon generated first term. B can be absent. So it can have only A. That means A is starting A and ending A. In between B, in between that it can generate any number of A's including epsilon. That means it can have one B, it can have n number of B's at the beginning, at the middle, starting with one A and ending with one A, and so on, right? So logic will be like, first you have to understand the logic, then you can able to design the transition diagram. So first, as you all know that you have to read the input from the input tape, and for our conventional way of writing the logic, this is one of the logic you can use it. It is left to you. You can replace that small a by capital A, need not to be capital A, you can replace by some other symbol. So you can replace small a is by a capital X or some other symbol. It is left to you people. However, you can read that logic and write a transition diagram. In this case, I have used that read A replace by small a by capital A. You have to write like this. You can use the arrow marks or bar, you can use it. Both the cases are holds good for in this design. Okay. Then once A is ready, the one A I read it and replace that A by capital A. Then the second move is, if your head is moved to the next symbol, that may be, that is a B always. One B, read all B's, that is, it can be have one B or it can be two B's or three B, n B it can be. Read one after the other and replace it by capital B, that is, you have to write it like this. Okay. Then look at that, underline this. Okay. Then in case, suppose it is a B star, it can generate a epsilon, so that B could be absent in that place. Okay. That's the cases. If no B found, you have to skip this logic. Second step. Then the third step, read A, okay, replace that A by capital A. Okay, look at that, how this you have to write it like this. I'll show this in the animated way. I'll take a tape. What is the input I have taken here? So that is, delta is indicating a blank symbol. I have taken the data, input is A, B, A. So first you have to read the delta. Always you have a pointer is pointed to the blank. Then you have to start with that. So read that delta. So delta is replaced by delta. Then move one step to the right. Look at that, how arrow is shifting to the one step to the right. So now it is A. What is the logic here? The first logic is read small a, replace small a by capital A. Okay. Now you read it and update it by capital A. Okay. You done that. Move one step to the next symbol. So that means write. So again, so step 2 says read all B one by one. In this case, there is only one B. You read that B, replace by capital B. Move one step to the right. Okay. So look at that. So what is the next one? It go to the step 3. Step 3, read that small a, replace by small a by capital A. Then move one step to the right. Look at that. So that means there is no more symbol. Okay. You read that delta, replace by the delta and stop. Okay. So look at the similar way of, I have taken one more example for better clarity to try to understand this logic. So look at that, you read that A, replace by capital A, then again B, again there is one more B, read all that B one by one and move to the next symbol. So this also, okay. Similarly for this another example, move, you read that small a replaced by small capital A, again A. So like that you can take any combination of this starting with A and ending with A, in between any number of A can come. Okay, hope you understand this concept. Let us move to the design of Turing machine by drawing the transition diagram. Okay. Okay guys, once you understand the logic, now you have to write the transition diagram for this given language. For that you have to take the similar tape here. The string is A, B, A. Both the side is, it is starting by blank symbol and ending by blank symbol. Now, so the head is pointed to the blank symbol and reading it and move one step to the right. Look at that. So this start an initial state, read the delta, moving one step to the right. So read the delta, replace by delta, moving one step to the right. That R indicates one step to the right. Now we are at Q1. So similarly, the head is moved to the right. Look at that. So head is now pointing to the small a. So as per our logic in the previous slide, look at what is the logic. Read the small a, replace small a by capital A. Read that small a and replace by capital A and move one step to the right, then you are reached to the Q2. Similarly, after that reading A, replace it by capital A, move one step to the right. Look at this. That is the convention as given here. Now we are at the Q2 and head is pointed to the B. Read that B, that means here have to follow the logic of our previous slide. That means logic, step number 2. Read B one by one. So replace that B by capital B, move one step to the right. So read that all the B. In this case there is only one B. If I have more than one B, also read it. That's the reason I have created a loop over the Q2. Right? B small b, replace that small b capital B, move one step to the right. Then similarly, so head is move one step to the right. So read again, there is a symbol as per our logic in the step 3, read that small a, replace by small a by move one step to the right. So Q3, right? So then finally you read all that A, okay? So reach to the end, right? So there is a delta. Read that delta, replace that by delta and stop. That is, you are reached to the final state. So you all understood that this concept, but thing is that you may not know which string it can start. It may be after reading a delta, it may be start with B. In this case, you should be reject it. So you have to read that B, replace that by capital B and move one step to the right, it go to the rejecting state. At the same time, suppose A, it is start with A, after that B will come, after that A come, after that it may be A or B came, that also it is a rejecting state. So it will go to the rejecting state. So that is rejecting string. It will read that A, replace by small capital A, move one step to the right. Similarly, B can come after the last A, B should read it, replace that B small b by capital, move one step to the right. So this is all, it is a rejecting. This will be the final control of Turing machine, that is a transition diagram. So hope you understand this. We will be come up in the next video. More example on Turing machine. We'll be taking a complicated problems. So hope you understand. Today I will wind up this problem with this problem, and hope you understand all the operation and designing simple problem I have taken this. Try to understand this problem. I will take some more problem in the next video. Thank you.